Good evening, dear student. I am going to start the chapter that is liquid solution, and in which I will describe Raoults law. Okay? What is vapor pressure? The pressure, the pressure exerted by vapor on its liquid state, liquid surface, that is called vapor pressure. Vapor pressure, vapor pressure of any gas is directly proportional to the 1 by intermolecular force. Okay, if intermolecular forces is strong, the vapor pressure will be decreases. What is the relation between vapor pressure and boiling point? Okay, vapor pressure and boiling point are inversely proportional. Okay, now I will describe the Raoults law. The partial pressure, the partial pressure of each component each component is directly proportional to the mole fraction pressure. Means this vapor pressure exert pressure on its liquid surface. Okay, understand it? When we boil this solution having XA component XB, mole fraction of A and mole fraction of B, when we boil this solution, it will form the vapor pressure. The condition is when both solute plus solvent and solvent are in same phase, means liquid, and now volatile, both are volatile, it goes from the vapor pressure. Means A is volatile and B is also volatile. Both are volatile liquid. Okay. Next thing, Raoults satisfied solution. Raoults satisfied only first for ideal solution. This is right for ideal solution. Okay. It means partial pressure of each component is directly proportional to mole fraction and into pressure of its pure form for ideal solution. Okay. Now, if A is more volatile, A is more volatile, we will draw a Raoults law. Okay, graph of Raoults law in for ideal solution. What happened with this graph? We will show the graph here pressure. Okay. When A is more volatile, means its vapor pressure is higher than B. Okay. Its vapor pressure is higher than okay. Now here x component is 1 and xb component is 0. Here xa component becomes 0 and xb component will become maximum 1. Okay. When we start, when a is greater than b, a is more volatile than b, then what happens? Means the vapor pressure of b is less than a. Okay. Here PA is the P and this is straight line function. Okay, it is PA and this one is PP. Okay, and this is PP. It means PA plus P. Okay, actually what happened? The total pressure, total partial pressure, it is total pressure or partial pressure. Total partial. Okay, PA plus PB. This is the total pressure. Okay, and according Okay. Here YA is equal to PA upon PP. From here P naught A into XA upon P naught A. Okay. Previous we have written P naught A plus P naught B minus P naught A into XB. In the same way, YB is equal to P naught B into XB, okay, upon P total, okay. You can write here in the same way is P naught A plus PB naught minus P naught A. On this formula, we will write direct numerator. What is YA? Mole fraction of A, mole fraction of A in vapor phase. Okay. What is YB? Mole fraction of B in vapor phase. Okay. From here we will solve one numerator, then we will move towards. Numerator is if pure form of a component having pressure 300 mm Hg and pure form of B component having pressure 600 mm Hg, okay, and total partial pressure of the solution is 500 at 500 mm Hg at 325 Kelvin. Okay, calculate. Find the composition of each component. Okay. Second, find composition of each component in vapor phase. Okay. First, what is given? Pure form of A having pressure 300, pure form of B having pressure 600, and pure total partial pressure is 500 Hg at 315 Kelvin. Find the composition of each component and component of each in vapor phase. Right here. Component Okay, what is P naught A? Pressure of pure component. Component A. Okay, what is PV naught? Pressure of pure component B. Okay, PV is total pressure given. Okay, from this formula, put the value there. Total pressure is given to be 500 mm Hg. What is P naught A? From the question, P naught A is 300 mm Hg and P naught B is 600 mm Hg. Okay, and PB is 500 mm. Right here. In this formula, what is P naught A? 300 mm Hg plus what is PV naught? 600 minus P naught A 300 into Xp. We have to find only Xp. Okay, from here. Next page. 500 is equal to 300 plus 600 minus 300 into Xp. Okay, now we will solve 300 plus 300 Xp. Take common 300 1 plus Xp. Right here 300 500 upon 300 is equal to 1 plus Xp. Now Xp will be 5 from 3 minus 1 2 by 3. It means Xp value is 2 by 3. Now you know that Xa plus Xp is equal to 1. That's why Xp means 1 minus Xa is equal to 1 minus 2 by 3. Okay, means 1 by 3. What is the ratio? Xa is to Xp is equal to 2 upon 3, 1 upon 3. It means 2 is to 1. What is the answer? Combination of each component Xa versus Xp is equal to 2 is to 1. This is the final answer. Each component. Okay, we have to find the component in vapor phase. Y is equal to P upon Pt. Okay, means P naught A into Xa upon P naught A. P naught A, Pb naught minus P naught A into Xb. Put the value here. P naught A was 300 into Xa 1 by 3 upon P naught A 300 means P naught is given 500. P naught is given 500 in the question. Y is equal to P naught A into Xa upon Pt. Okay. P naught A 300 into Xa. Xa is 1 by 3. From the previous value we will put and Pt is given. Put the value Xa is equal to 1 by 3 and Pt is equal to 500 is given in question. Okay, and P naught A is equal to 300 from the question. Okay, what is the value? This. What is the value? 100 upon 500 means 1.5. Means Ya is equal to 1.5. Second one, Yb is equal to B upon Pb naught into Xb upon Pt. Okay, Pb naught is 600 into Pt. Xb is 2 by 3 upon Pt is 500. Okay, and 2 to the 4, 415 is the answer. Means Yb is equal to 4.5. What is the ratio? Y versus Second graph, Raoults law for Raoults law for positive deviation and negative deviation. Okay, here we will draw a graph. When PA, right here, this was the ideal solution. Here we will write the ratio PA naught. Okay, PA this one is PA and this one is PP and this one is PP. But when pressure of the component is greater than 0, okay, greater than PP, then what happens? Okay, this will be PA will be from here and PP will be also greater than due to pressure. Means pure form pressure is greater than normal form. Okay, it will be form not like this and total pressure will be from here. Okay, the positive deviation means more volatile components are present. Here example is CCl4 plus C6 axis. Okay, CCl4 plus okay. The second graph will be Raoults law for negative deviation. Okay, draw the graph here. First, we draw the normal ideal solution graph. Okay, this is the Raoults law graph for ideal solution. Okay, the equation and reflection A is equal to 1, A is equal to 0. Okay, XB is 0, but XB is 1. Negative deviation, it means the vapor pressure will be less than total pressure here. Okay, and this will form graph here. Okay, and this will also form the graph here. If you look simple, okay, we'll draw the graph of V. It's normal. Okay. Next, what is the graph of this? From below. Okay. This is for negative deviation. Okay. Acid solution with any one form like water. Acid solution, it means it will form the means polar plus non-polar compound will give the negative deviation. Okay, what is the ideal solution? Obey Raoults law. Means delta H mixture is 0. Delta B mixture is 0. Okay, delta Z is negative. Delta S is greater ethane, okay, or butane. Anything which are same sound. Raoults law, the graph will be straight line.